How does JavaScript tree shaking work with ESM? Imagine building a big Lego set and only wanting to keep the pieces you actually use. That's kind of what tree shaking does for your JavaScript code. It helps make your website faster by removing unused parts. Now, this process works best when you use a special way of organizing your code called modules, or S-modules. These are a way to split your code into separate files that can talk to each other. S-modules use static import and export statements. That means you tell the code what you need upfront, and it stays fixed. Because of this, build tools like Webpack, Rollup, and esbuild can look at your code before it runs. They analyze which parts of each module are actually used and which are not. If a function or variable is never imported or called, it can be safely thrown out. This is the core idea behind tree shaking. Another important aspect is side effects. Some modules do things when they are loaded, like change the web page or start a timer. To help with tree shaking, packages can declare in their package.json file that they have no side effects. This tells the build tools that it is safe to remove unused code from those modules. Modules also encourage splitting code into small, focused files. This makes it easier for the build tools to remove entire modules that are not used at all. When you use named exports instead of default exports or importing everything at once, it becomes easier for the tools to identify and remove only the parts you don't need. Modern build tools like Webpack, Rollup, Vite, and esbuild relying heavily on the static nature of S-modules. They analyze the entire module graph, find out which exports are actually used, and then exclude the rest from the final bundle. But keep in mind, if you use older style modules like CommonJS, tree shaking becomes much harder or impossible because their imports and exports are dynamic and unpredictable. In web development, you can do a lot to make tree shaking work better. Use S-module syntax consistently, set the side effects property to false in your package.json when possible, and structure your code with small, focused modules. Also, choose dependencies that support S-modules so you can reduce your bundle size. Tools like Source Map Explorers can help you see what code is actually included in your final build. To sum up, JavaScript tree shaking with S-modules works by analyzing static import and export statements, identifying unused code, and removing it before your website loads. This makes your site faster and your code cleaner. Mastering this process is a key part of writing modern, efficient JavaScript for the web.